Hey everyone, welcome back to the College Algebra playlist. In this video, I want to take everything we've learned about the behavior of graphs and the composition of functions and apply it to some concrete examples. Alright, so let's dive into it. Okay, here we go. Example 98. Here we're asked to use the graph of the function to determine the intervals on which the function is increasing or decreasing. Alright, so remember, when we read a graph like this, we read it from left to right like it's a sentence in English. Okay, so from left to right, we can see that the function is decreasing and then increasing. So the question is, what are the intervals over which the function is increasing or decreasing? Alright, we can see here that the function decreases from negative infinity up to positive 1. Alright, we're looking at the x values. Alright, and it increases on the interval 1 to positive infinity. Okay, so that's the behavior of this graph. Let's look at another problem like that where we're asked to determine the behavior of the graph, meaning we want to find out where the function is increasing or decreasing. Alright, so we read this function again from left to right, and we can see that it increases from negative infinity up to negative 3. Alright, and then it decreases from negative 3 to positive 1, and then it increases from 1 to positive infinity. Alright, so that's the behavior of this graph. Another way we can talk about the behavior of graphs is to determine local extrema and absolute extrema. Alright? So let's take a look at this graph closely and see if we can find local extrema or absolute extrema. Alright? Let's take a look at these 2 points here. Alright, this blue point and this red point. The blue point is a local minimum, alright, because this is where the function switches from decreasing to increasing. Okay, so the function has a local minimum at negative 2, negative 2, alright, and it has a local max at 3, 1, alright, because that's where the function switches from increasing to decreasing. Alright, but this function does not have any absolute extrema. Alright, why is that? It's because the function continues up to positive infinity over here, and it continues down to negative infinity over here. Alright, so there is no biggest or smallest y value. Alright, so this function only has local extrema right here at this blue point and this red point. Alright, this function is different though. Alright, let's take a look at this. Here we have the blue point negative 2, 1 and 2, negative 2. Alright. So we can see that the function switches from increasing to decreasing right there. Okay, so it has a local max at negative 2, 1. And it has a local min at 2, negative 2, because that's where the function switches from decreasing to increasing. Okay, so that's a local min. Alright, next, let's take a look at these 2 black points. Okay? This is the smallest y value that the function achieves. Alright, negative 4. Okay, so the function has an absolute minimum at negative 4, negative 4. And 3 is the highest y value. Alright, so it has an absolute max at 4, 3. Alright, so that's how we can describe the behavior of this graph. Alright, next, let's shift gears and talk about combining functions. Alright, in the next example, we'll take a look at composition of functions. But for now, let's just start simply with this. Alright, given the functions f of x equals x squared plus 2x and g of x equals 6 minus x squared, find and simplify f plus g, f minus g, fg, and f over g. Alright, so let's start here with f plus g. Alright, f plus g of x, right, that's just when you take both expressions and you add them together. Alright, that's all we're doing. Okay? So f of x plus g of x is x squared plus 2x plus 6 minus x squared. All right? And we can see here that the x squared and the negative x squared cancel additively. All right? So that just leaves us with 2x plus 6. And that's my final answer for f plus g. All right? Next, let's take a look at f minus g. All right, f minus g of x is equal to f of x minus g of x. All right? So we're going to take x squared plus 2x and then subtract this entire thing. All right, so we'll use parentheses. All right, we'll subtract g of x, which is 6 minus x squared. Okay? So what we need to do to simplify this is distribute this minus sign into each piece in the parentheses here. All right? And that gives us minus 6 plus x squared. All right? And here we can see that we have some like terms, right? X squared and x squared we can combine together to get 2x squared. All right, so we have 2x squared plus 2x minus 6. And that's my final answer for f minus g. All right, next let's look at fg. All right, that's just when we multiply the expressions. All right, so we'll have something to FOIL here, right? We have x squared plus 2x times 6 minus x squared. All right, when we FOIL this, we get 6x squared. That's my firsts. And then my outers, right, that's negative x to the fourth. And my inners, right, that's 12x. And my lasts, right, that's negative 2x cubed. All right? So when we report our final answer here, we want to put the powers in descending order. All right? So we have negative x to the fourth minus 2x cubed plus 6x squared plus 12x. All right? That's the traditional way to report the final answer. All right, so fg is equal to this. All right, next, let's take a look at f over g. All right? This is when we divide the expressions. All right? So this one isn't that interesting, right? There's not much simplification that can be done. Well, there's no simplification that can be done, right? We have x squared plus 2x over 6 minus x squared, and that's our final answer. All right, so that's f over g. So these are 4 ways that we can combine the functions f and g. All right. In this example, we're going to get into some function composition. All right. Given the functions f of x equals 2x squared plus 1 and g of x equals 3x minus 5, find and simplify f circle g and g circle f. All right, f circle g, right, that's when we take g of x and we use it as the input for the function f. All right, so we have f of g of x, which is 3x minus 5. All right, f of 3x minus 5, that's what we're doing. But what does the function f say to do? It says to take what you're given and square it, multiply by 2, and then add 1. All right, so that's exactly what we're going to do here to this 3x minus 5. Take what we're given and square it, multiply by 2, and then add 1. All right? Expanding this out, we have 2 times this plus 1. All right? So we need to FOIL this right here. All right? And that's going to give us 9x squared minus 15x minus 15x, so minus 30x, plus 25. All right? And then we have this plus 1 tagged onto the end. All right? So the next thing we need to do is distribute this 2 to each piece in the parentheses here. All right? So we'll get 18x squared minus 60x plus 50 plus 1. All right? So the last thing we can do to simplify this is we can combine these constants at the end, and we'll get 18x squared minus 60x plus 51. All right? That is f circle g. All right? Next, let's take a look at g circle f. All right? G circle f is g of f of x. All right? So we're taking g of 2x squared plus 1. But what does the function g say to do? It says to take what we're given, multiply by 3, and then subtract 5. Okay? So we'll take what we're given, multiply by 3, and subtract 5. All right? Let's distribute this 3 to each piece in the parentheses here. And that gives us 6x squared plus 3 minus 5. All right? And 3 minus 5 is negative 2. So our final answer for G circle F is 6x squared minus 2. Here we're doing the same thing. All right, we have two different functions though. We have the functions f of x equals x squared plus 1 and g of x equals the square root of x plus 2. All right, so let's start with f circle g. All right, let's find out what this composition is. All right, f of g of x is equal to f of the square root of x plus 2. All right, so what does the function f say to do? It says to take what we're given and square it and then add 1. All right, so all we're going to do here is take this and square it and then add 1. All right, the square root of something squared is just equal to the something. All right, so we have x plus 2 and then we have this plus 1 tagged on to the end. All right, x plus 2 plus 1 is x plus 3. So that means that f circle g is equal to x plus 3. Next, let's do g circle f. All right, g of f of x is equal to g of x squared plus 1. All right, so what does the function g say to do? It says to take what we're given, add 2, and then take the square root of that whole thing. All right, so we're going to take this and add 2, and then take the square root of that whole thing. All right, the next step we can take is to get rid of these unnecessary parentheses. All right, so we have the square root of x squared plus 1 plus 2. All right, 1 plus 2 is 3. So we just have the square root of x squared plus 3. And that's my final answer for G circle F. All right. Last problem. This is a word problem. All right, so this is pretty interesting. A forest fire leaves behind an area of grass burned in an expanding circular pattern. If the radius of the circle of burning grass is increasing with time, according to the formula r of t equals 2t plus 1, express the area burned as a function of time, t, in minutes. Okay? So we know that the area of a circle is given by the formula a equals pi r squared, where r is the radius of the circle. All right? So that means we have two functions. All right, we have a of r, right? The area is a function of the radius. A of r equals pi r squared. And r of t, right? The radius is a function of time. R of t equals 2t plus 1. So the area burned as a function of time is given by the composition a of r of t. All right? So let's take these two functions and compose them and see what we get. All right? We have the two functions a of r equals pi r squared and r of t equals 2t plus 1. So we're going to take a of r of t and determine what that is. All right? A of r of t is equal to a of 2t plus 1. All right? But what does the function a say to do? It says to take what we're given and square it and then multiply by pi. Okay? So we have pi times 2t plus 1 squared. Okay? So what we can do next is expand this. All right? And when we FOIL it, we're going to get 4t squared plus 2t plus 2t. So we have plus 4t. And then we have plus 1. All right? So the last thing we need to do to simplify this is distribute this pi to each piece in the parentheses here. All right? And that's going to give us 4 pi t squared plus 4 pi t plus pi. All right? And that's my final answer for the function a of r of t. All right? So that's what the function composition looks like in this case. that does it for this video. Thank you for watching, and like and subscribe.